Now we're going to look at a simple application of these ideas. If you go and download Python, you'll see these numbers to the left of the different downloads. These are checksums. A checksum function maps long files to short sequences to enable you to check whether a file you've downloaded has been corrupted. So the web page shows the checksums of the files you can download. If you download a file, you run the checksum function on it. And now, if the result of running the checksum function on the file you downloaded isn't the same as the result posted on the website, you know the file has been corrupted en route. But what about the other way around? Could it be that the file is corrupted, but you don't detect it by running the checksum? It could. It could happen, but how likely is it? We're going to use a sort of toy checksum to illustrate some of the ideas we've been exploring. So the checksum function looks like this. We're going to represent a file as an n vector over GF2. That is an n-bit sequence. And the function will be a 64 vector over GF2, where the first entry is a1.x, the second entry is a2.x, and so on. So, and where a1 through a64 are vectors we chose somehow. So here's our checksum function. It takes an n vector x over GF2, and it outputs the dot products a1.x, a2.x, up to a64.x, where a1 through a64 are vectors we choose somehow. Now let's use p to denote the original file, and say it is randomly corrupted during the download process. What's the probability that that corruption went undetected? Here's the checksum of the original file. The first bit is a1.p, and we'll denote that by beta 1, and so on. Now, let's write the corrupted version as p plus e. Remember, we're doing GF2 addition, so in this case, e has 1s precisely at the positions in the file that were changed during the download process. Then the checksum of the corrupted file matches the checksum of the original file if and only if the first bit matches, a1.p plus e equals beta 1, the second matches, and so on down to the 64th. That's true if and only if the difference between the first bit of the checksum of the original file and the first bit of the checksum of the downloaded file is 0, and so on. And that's true if and only if the error vector satisfies these equations, a1.e equals 0 through a64.e equals 0. In other words, if E is a solution to the homogeneous linear system, a1.x equals 0 through a64.x equals 0.